Divide x cubed minus 2x squared plus 6 by x plus 3. You could do this by that jiggling method, but let's just do the division. Now we have to be careful here because we have a cubed term, squared, no x term, and then a constant term. Now we'll deal with that by doing the following. X cubed minus 2x squared plus 0x's plus 6. Because this works as a column going down, you have to put that 0x in there. Now, what do we multiply x by to get x cubed? You multiply it by x squared. Then multiply the x squared by x and 3, and we get x cubed plus 3x squared. Now subtract, and we'll get negative 5x squared. Bring down the 0x's. What do we multiply x by to get negative 5x squared? You multiply it by negative 5x. Multiply negative 5x by both things here, and we get negative 5x squared. Take away 15x, and subtract, which gives us 15x. Bring down the 6. What do we multiply x by to get 15x? We multiply it by 15. And 15 by both things there is going to be 15x plus 45. And if we subtract, we get negative 39. So what we can see there is that we have a remainder of negative 39, a quotient of x squared minus 5x plus 15. Now, we want to express x cubed minus 2x squared plus 6 in the form x plus 3, q of x plus r. Q of x will be a quadratic and r is a constant. We can see that from our working above. So, x cubed minus 2x squared plus 6 would be equal to x plus 3, that's the divisor, multiplied by the quotient x squared minus 5x plus 15, take away 39. And so that part is done. Let f of x be equal to x plus 3 q of x plus r. Your expression from b. Evaluate f of negative 3. If I do f of negative 3, it's going to be negative 39. Let's think about why. I'm substituting in x is negative 3. That means that that bracket there, this one, becomes 0. So we've got 0 times this bracket, and it doesn't matter what that bracket is, it will be 0, and I'm left with the remainder of negative 39. We're working towards something here called the remainder theorem. If our f of x is the original x cubed minus 2x squared plus 6, f of negative 3 would be negative 39. Quite often, that was explained down here, by the way, because we know that that is equal to that. And quite often, we're not interested in the quotient, we're only interested in the remainder. And so we can find the remainder on division by x plus 3 by simply evaluating f of negative 3. We've got a couple more examples that show that, and then we'll talk about the remainder theorem itself.